Hello, and welcome to Aggressive Physics. Today is day 101, and what I'd like to do today is begin our discussion of static electricity. Now, static electricity is when electrons are stored up on a single object and they are released from that object and turn into current electricity. Static is the buildup of extra electrons. Now, the most common demonstration of this is the Van de Graaff generator. And what I'd like to do today is discuss how the Van de Graaff generator works. The Van de Graaff generator is merely a device that moves a rubber belt around a plastic spindle. And as it travels around that spindle, there's friction between the belt and the spindle itself. Now, when that happens, the friction causes extra electrons to be removed from the belt. Those electrons that are extra travel along the belt, and at the top of the belt, there's a little metal comb that allows the electrons to jump off. As you may remember from an earlier course, like charges repel. So all the electrons on the belt try to repel one another. Now, what happens in this case is that comb at the top allows the electrons to jump off of the belt, and they collect at the top of the Van de Graaff generator. The top of the Van de Graaff generator is typically a metal sphere. Now, that metal sphere will build up charge, and the Van de Graaff generator can store a bunch of charges. So all those extra electrons are storing up together, they're jumping apart, and they are trying to repel one another even more. Well, ultimately, there'll be an excess of charge that's so great that they will release. Now, if it's a humid day, what will often happen is that extra electron, that extra static electricity, will be released into the atmosphere. So sparks will form on the Van de Graaff generator and be expelled into the air, grabbing onto the moisture in the air. Now, if you have a dry day, you can actually perform experiments with that, and people will often hold the Van de Graaff generator and store extra charge on themselves. And that can be released in many different ways. Now, in class, what will typically happen is we'll show a number of demonstrations using the Van de Graaff generator. That is a standard beginning to the static electricity chapter. And what I will do in class is show a number of demonstrations about how the Van de Graaff generator can be used to store electricity. But what's important to realize is that static electricity is the storing of excess charges on an object. And we can, in this case, we're releasing the extra electrons from the belt by friction with the plastic spindle. And then those electrons are then stored into the metal sphere at the top of the Van de Graaff generator. So that's how the Van de Graaff generator works. And what we'll do now is talk about the history of the Van de Graaff generator in a little more detail. Thank you. Now, the Van de Graaff generator was invented by Robert Van de Graaff, and he worked for MIT at the time. But there's also another device called the Tesla Coil, and that was invented by Nicholas Tesla. And what he did is he used a transformer to step up the voltage from the line current, which is 120 volts here, and he stepped it up to a much higher voltage. He used a device with electronics in order to produce a large static charge. So the Tesla coil was invented. And basically, the principle is that he takes the 120 volts and uses a transformer to step up the voltage, and then there's a little gap, a spark gap. Well, there's a capacitor at that point that stores charge. A capacitor's job is to store charge, much like the sphere on the top of a Van de Graaff generator. Well, as it stores charge, what will happen is eventually it'll get too great and it will release across that spark gap. And when it jumps across the spark gap, it will release a high voltage bolt. Basically, these are lightning bolts at a much smaller scale. The end of the Tesla coil will usually be metal, and that's where the charge can jump from to another device. Now, this is another demonstration that I typically will do in class. So we'll look at the Van de Graaff generator and the Tesla coil during class. What Tesla also did, and this we'll talk about a little later in the chapter, is that he understood that the electric field inside of a conducting sphere was zero. And there's a famous picture of him inside this great metal cage, and he's reading the paper, sitting down reading the paper while lightning bolts are all around him. And you're perfectly safe inside of a metal conducting conductor. That's why you're safe inside of your car. That's why you're safe inside of a metal cage if you were to be in like a dugout for a baseball game. You're actually safest inside the dugout if it's made of metal all around. And the only thing you have to make sure you do is keep your hands inside the cage itself. So a lot of people believe that cars are safe in a lightning storm because of the grounded tires, because the tires are made of rubber. The reality is that you're safe inside of a car because the frame of the car is made of metal and you're inside the frame. Even though there are big openings, if you're struck by lightning, all of the lightning will travel along the outside of that cage. There is a demonstration at the Boston Museum of Science that utilizes the same principle. They have huge Van de Graaff generators, the ones that were actually invented by Robert Van de Graaff. And what happens is the person who's running the show will be inside a huge bird cage, and it's made of metal. And they'll make a point of being struck by the Van de Graaff generator's bolts and put their hands on the inside of the cage. If they were to hold their hands around the bars themselves, then they would be struck by lightning and be killed. But you're perfectly safe inside of a metal conductor. So if you find yourself, let's say at a beach and there is no protection from a thunderstorm, if you could find yourself a nice metal trash can, go inside of that, or put it over yourself and keep yourself completely balled up inside of it, you should be completely safe. Of course, you should probably find shelter inside a building. It's much safer in a building. But as a last-ditch effort, metal garbage cans are the way to go. Maybe even find a dumpster to jump in. And then maybe there's some good stuff inside the dumpster that you could bring home later. But that's the Van de Graaff generator and the Tesla coil, two classic examples of static electricity, and usually something that begins the discussion of static electricity in class. And we'll look at that during our lecture class. Thank you.